Hmm.
Greetings, everyone. We are from the team, the Byte Club. We have chosen the team Improved Onion Storage Technology for Enhancing Shelf of Onion Life under the theme Agriculture, Food Tech, and Rural Development. India is the second largest producer of onions, contributing nearly 25 million tons annually. However, due to poor storage infrastructure, 30 to 40% of the harvested onions are lost every year, mainly due to sprouting, rotting, and weight loss. The need for controlled environments. Onions require specific environmental conditions to extend their shelf life. The optimum temperature is between 25 to 30 degrees Celsius, and the optimum relative humidity is between 65 to 70%. Any deviation from these conditions accelerates sprouting, microbial activity, and decaying. The traditional onion salts rely on natural ventilation, which is highly sensitive to external climate. Lack of real time monitoring causes unregulated temperature and humidity. Excess humidity promotes fungal growth, while low humidity leads to shrinkage and weight loss. Accumulation of gases like hydrogen sulfide and volatile organic compounds further reduces the onion quality. Annual post harvest loss of onions are valued at 8,000 to 10,000 crores in India alone. Farmers and traders face heavy losses due to the unpredictable price fluctuation caused by large scale spoilage. The need for a smart storage system is here. We are designing a smart IoT onion storage warehouse which can address this issue by continuously monitoring key parameters like temperature, humidity, and gas levels using ESP32 with sensors and automatically regulate the environment with fans and humidifiers. This ensures reduced spoilage and wastage, longer shelf life, and preserved quality, cost saving for farmers and cooperatives. A scalable, energy efficient, and sustainable solution can address this issue and reduce the spoilage of onions. Over to Chetan.
Now, as we come to the technical approach, what we have used a ESP32 microcontroller as the main base controller for all the activities which we're gonna do. And as we are using ESP32 controller, this act as a server as which controls the data acquisition and the environment control modules. As we choose the low power consumption in integrating Wi-Fi and Bluetooth capabilities, making it ideal and IoT applications. It receives the sensor data, processes it against the ideal conditions, and sends the signal to the actuators. And the sensors which we're gonna use in this are temperature sensor, gas, and humidity sensor. As the network relies on the sensors, the continuous monitoring of the storage environment. This specifies the environmental temperature, humidity, and concentration of the gases like hydrogen sulfide and volatile organic components. As we comes to the actuators, we use a fan and the humidifier. The device system controls the elements regulated by the ESP32, and they are used to take the necessary actions. The fan is used to adjust and improve the natural airflow and reduce the hot spots, and the humidifier or mist is used to regulate the humidity within the storage structure. Now, coming to the power supply, the unit ensures that the system has necessary power to operate with the design prioritizing low power use and ability to operate with the solar backup in the rural areas. Now, coming for the data flow and user interface, the technical approach integrates hardware, software, and communication to enable the remote and data-driven management. The data acquisition and storage comes with the hardware operation as a wireless sensor network, where sensor data and the parameters is collected and wirelessly transmitted. The long-term storage are performed on the cloud for analytics. And coming to the user interface is accessed via Wi-Fi. The interface allows the remote monitoring and currently storage condition and remote control of the system. Critically, the system offers alert to the authorized farmers with necessary enable that quickly responds to the storage issues and take the time corrective actions. And now coming to the feasibility and viability, it is easy to integrate as we use the components like ESP32 and the temperature humidity sensor mist maker, which it is reliable and well understood by the user. And it uses a retrofit design where the critical elements are designed in the low cost retrofit. it can be added on the existing oil wells without requiring major reconstructions with design specific and minimize initial investments. And affordable and financially, it is well helpful where the initial cost of the development is very low, as the barriers of entering minimal individual farmers and corporates. And it helps in the and it also raises the rapid payback period where it controls the spoilage of the onions. And it is sustainable as we use a low power consumption. It focuses on the low power usage as a key efficient operation. And we use as a solar powered operation for the backup where if there is anything problem with the power generation, as we use the solar as a backup, it will be used in rural areas. And coming to the scalability and deployment, the design and architecture also of the basic deployment and scalability in the different sizes of storage for small farmers unit, multiple warehouses or corporate storage facilities. And the intelligent control system is adapted to any regions, allowing it to maintain optimal storage conditions despite various temperature and humidity levels. And coming to the human interface, the intelligent system provides automated operation, adjustment of environment, and maintain optimal conditions. This significantly minimizes the human intervention and saves the labor time. And with using the real-time alerts, the user-friendly interface provides the real-time alerts, enabling farmers to quickly respond to the potential storage issues, which promotes wider adoption and efficient utilization of the technology. And the system is designed for minimal maintenance, further reduce the need of constant human oversight. Over to Ashish Aryan.
Now I'm going to explain about the impacts and benefits. The first thing what we get from impacts and benefits is minimizing post-harvest losses. The system directly addresses the critical challenge of post-harvest loss by significantly reducing onion spoilage, rotting, and sprouting, thereby extending the commercial storage life and preserving market value. And the next thing will be data-driven environmental control, continuous monitoring of critical parameters like temperature, humidity, and real-time data logging to the cloud facilitate proactive and intelligent adjustment to the storage environment, moving beyond passive storage methods. And the next thing will be the operation efficiency and low cost of ownership. By utilizing low cost, proven components like ESP32 standard sensors, the system offers an affordable retrofit solution for existing onion stalls without requiring major reconstruction. This ensures a rapid return on investment with potential saving exceeding the system's cost. Energy independence and rural stability. Low the design prioritizes low power consumption and incorporates solar backup operation, making the technology highly sustainable and viable for implementation in remote or rural areas with unreliable power infrastructure. And the next thing will be scalable and decentralized deployment. The hardware is conceived as a low power wireless sensor network that can be easily scaled and adapted across multiple warehouses, corporate storage facilities, or individual farmer storage units with minimal modifications. And the last thing will be the reduced labor and enhanced response time. Automated operation minimizes the need for constant human intervention and labor. The user-friendly interfaces provides real-time alerts, enabling swift farmer response to potential storage issues, which promotes widespread adoption and effective migration of losses. Now, I would like to conclude the project that we had been discussing about now. The IoT-based optimized onion storage system is a pragmatic and technologically advanced solution that directly addresses the problem statement of enhancing onion shelf life through improved storage technology. Our solution is low cost, non-invasive retrofit that integrates an intelligent ESP32 based control module into existing onion charts. The system ensures optimal preservation by continuously monitoring and automatically regulating the internal microclimate, that is maintaining 25 to 30 degrees Celsius and 65 to 70% relative humidity. Key advantages include like sustainable operation via low power consumption and solar backup, scalability across various unit sizes, from farmer to industrial level, and a user-friendly interfaces that facilitates data-driven decision making and remote control. This system offers a clear economic advantage to the agricultural sector by drastically minimizing spoilage losses and maximizing the window for market sale, confirming its strong technical feasibility and commercial viability. Thank you.